In this video, we're going to take a couple more looks at writing these sort of expanded logarithms into a condensed form. And then finally, what we're going to do is we're going to look at the change of base formula. So we have this 1/3 times 2 log 5x minus log base 5 of y. We should always distribute first. All right, so let's do that to begin. And so that's going to turn us into 2/3 log base 5 of x minus 1/3 log base 5 of y. We're going to move any of these exponents, or sorry, any of these coefficients as exponents. So now we're going to get log base 5 of x to the 2/3 minus log base 5 of y to the 1/3. And then finally, what we're going to do before we write this into another form is we are just going to write this into a single log. Notice that we have a subtraction, so that implies division. So we're going to have log base 5. We're going to have the positive exponent or the positive coefficient in the numerator, and then the negative in the denominator. And one thing that we should be cognizant of is that a lot of times what we'd like to do is we'd like to write these expressions as radicals. Okay. So what we're going to do is we're going to go backwards. Anything that's in the denominator, that's going to be the index. Anything in the numerator, that stays the exponent. So I can write this expression as log base 5 of the third root of x squared divided by the third root of y. And because they both have the same radical, the 1/3, what we could do is we could put that under the same radical expression. So we could write this as log 5 of the third root of x squared over y. All right. So now just be careful as to what my math lab wants. And realistically, all the stuff that we're doing is just algebra steps. So it's not too bad. But we want to be cognizant of, how we try to write this in that into our my math lab. All right. Last example of this, we have a 1/2. So we're just going to distribute just like we've done a lot of times already. And so this is going to become 1/2 ln of x plus 1 plus, now 1/2 times 2 is going to be 1. So we're just going to write this as ln of x minus 1, and then plus 6 ln of x. Any coefficients are going to become exponents, so that's easy enough. So now we're going to get ln of x plus 1 to the 1/2 plus ln of x minus 1 plus ln of x to the 6th. Everything's positive. So what we're going to do is we're going to write this as a single logarithm, except everything's going to be multiplied together. So this will be ln of x plus 1 to the 1/2 times x minus 1, and then times x to the 6th. We don't like to have any sort of fractional or rational exponents. So this is just going to be a square root. Okay, so remember, if you have something like y to the 1/2, that's the same thing as the square root of y. So this is going to be ln of the quantity root x plus 1, and then x minus 1 quantity, and then x to the 6th. All right, and that's probably as simplistic as we can write it without going through and doing any sort of really horrible algebra to be able to simplify. All right. So one last thing that we're going to learn in this section is the change of base formula. And the change of base formula is actually really easy. If we have log base b of x, we can use any logarithm base that we want, and we can write it as log, whatever that base a might be, x, log a of b, okay, or ln x over ln b. Or if we really wanted to, we could just use the common logarithm, log x over log b. All right. Probably, and I think in my math lab, they're probably going to want something like this if you're entering it. So just be careful about how they want it entered. All right. Usually, what we're going to do is we're going to use either ln or base 10. All right. And I'm going to show you that it doesn't matter which logarithm we use, which base. Okay. So let's use the change of base property to rewrite into a natural log or common log. And then we're going to express the answer in 4 decimal places by using a calculator. All right, so This log base 7 of 10 can be written as either log 10 over log 7. All right, so notice we just have whatever the base is going to go in the denominator. Okay, so our base, which is 7, goes in the denominator. Now, this is the same thing, and I'm going to show you in a moment, as ln 10 over ln 7. All right. Now, in our calculator, let's just see if that's valid or not. Let's see if we get the same approximation to 4 decimal places. All right. So in our scientific calculator, I'm going to have log. So if I go over here, here's log of 10. And I'm going to divide that by log of 7. All right. And notice that gives us 1.1833. All right. So that's going to be approximately 1.1833 just by approximating the 4 decimal places. All right. Let's see if I type that in as a ln. Okay. So if I type ln of 10 divided by ln of 7, it gives us the exact same answer. Okay, well, at least approximately in the calculator. So the good news is that it doesn't matter which of these logs you use, it'll still give you the same approximation. Okay, so just be careful in my math lab that you give them the log that they want. Okay, I think it's the log, but just be careful that they don't want the common logarithm. Log of 0.5, 14.9. That's going to be log of 14.9 divided by log of 0.5. All right. And then we just approximate that. We can go into our calculator. And again, it doesn't matter. So I'm going to have log of, I think it was 14.5, 14.9, excuse me. So log 14.9 divided by log of 0.5. All right, so we get negative 3.972. All right, let's see if that's the same if I use the natural log of 0.5. And notice both times we get the exact same thing, negative 3.8972. All right, so this is going to be approximately negative 3.8972. Okay, either way. Okay, or if we wrote it as ln 14.9 divided by ln 0.5. Okay, same thing. Right. Last one, we just flip these around and let's see what happens with that. So first we're going to write it as ln of 0.5 divided by ln of 14.9. And let's see what that gives us. So in our scientific calculator, we're just going to flip over 0.5, and then we have the 14.9, and that gives us negative 0.2566. All right, so that's going to be approximately 0.2566. All right, just verifying that the log does work for both of these. Let's just try log of that number. Okay, common logarithm. So log of 0.5 divided by log of 14.9. And not surprisingly, it gives us the exact same values. All right, so that's our change of base formula. Okay, and we've actually seen the change of base formula when we go to graph something. So that's one of the uses. If I had something like log base 3 of x and I wanted to see what the graph of that looked like, I could just go ahead and say this is ln of x over ln of 3, and I could graph that by just using our calculator. Okay, we probably saw this before, but we would have y equals ln of x divided by ln of 3. All right, and there we go. We get the graph of ln of, or I'm sorry, log base 3 of x. All right, so that's just a reminder that you can use this change of base formula to be able to graph functions. All right, so that's all that we have for this properties of logarithms. In the next video, what we're going to do is we're going to start solving equations that involve logarithmic and exponential sorts of expressions within those equations, and we'll see the techniques needed to solve those.